Moshi Moshi, this is section 2.6, which is theoretical and experimental probability. Those of you whose parents or grandparents go to Vegas, this is a good section to learn if you want to go with them and when you're 21 and want to go gamble. But theoretical probability is the probability of an event happening. And how you find the probability is the number of good outcomes or favorable outcomes over the total number of outcomes. Okay, or in short, good over total. Okay, so the probability of an even number, if you roll a 6-numbered die or a dice, what is the probability of getting an even number? So the good outcomes are 2, 4, and 6. And the total outcomes is 1, 2, 3, 4, 5, 6. Okay, so there's 3 good outcomes over 6 total. And you simplified it down, and your probability of getting an even number when you roll a dice is 1/2, which makes sense. 2, 4, 6 are the good ones, and 1, 3, 5 are the bad ones. You can also write it as a percentage if you want, but we can just leave it as a fraction. Okay. What is the probability of flipping a coin and getting a heads? Simple. It's just 1. The heads is good and favorable. There's 2 total. So the probability of flipping a heads is 1/2. What is the probability of having a month with 30 days? Well, if you know your months, April, June, September, and November, there are 4 months with 30 days out of 12 total. Okay, and when you simplify it down, 1 out of every 3 months have 30 days. Pretty simple. Okay, the complement, so that's probability. And they write it this way, the probability of an event, so probability of an even number, just so you know, okay? The complement is the opposite or different. It's probability of not happening. So instead of good over total, like the probability, the complement is the bad over the total. And they write it this way, the probability of not an even number. So if I showed you both of them, this is probability of an even number. They would say probability not of an even number. Not an even number, sorry. Probability of getting the heads. Probability of not getting the heads. And so you can see the word not in there. Okay, so when we come here, it's the same way, but you're going to bad over total. So not an even number. 1, 3, and 5 are the bad ones. There's still 6 total. So it's still 1/2. Probability of not a heads. So in actuality, you're looking for a tail, which means the heads, it's still 1/2. The probability of not getting a heads is 1/2 because the tail is the 1 and out of 2. The probability of a month not with 30 days, or not a month with 30 days, there are 8 months without 30 days, so it'd be 8 of them out of the 12. Because in this case, we said there was 4 of them that had over here. So that means there's 8 of them without. And when you simplify that down, divide by 4, you get 2/3. And if you notice, as I kind of keep them together here, when you add the probability along with the complement, it should equal to 1. So 1/2 plus the 1/2 is 1. 1/2 plus the 1/2 is 1. 1/3 plus the 2/3 is 1. And that's the reason, because you're looking for the good over the total here, the bad over the total there. So when you add up the good and the bad, that's all of them. That's the total. Okay. Odds. Odds is a little different than probability. Probability was good over total. Okay. Odds is good over bad, but you actually write it good to bad with a colon. Okay, so probability, remember, was good over total. This odds is good to bad. And there's 2 ways. There's odds in favor of something happening and odds against. Okay, so odds in favor is good to bad. Odds against is bad to good. So I use the same 3 examples. Odds in favor of getting an even number. So 2, 4, and 6, that's 3 good ones. But instead of out of 6, it's good to bad. So, and there's three bad ones that eat the odd numbers. So there's three good ones, 2, 4, 6. Three bad ones, 1 through 5. So the answer is 3 to 3. So I'm going to write it a little smaller. And then that would equal to 1 to 1. You simplify it down. Okay, so you still want to simplify it down. Heads, probability of getting a heads when you flip a coin. There's one good one, and there's one bad one, the tails. Okay, so in the probability it was 1/2, odds is 1 to 1. Month with 30 days, there were 4 good ones, and there were 8 bad ones. Okay. And you get 1 to 2. Okay. So probability and odds you can see are different. Okay. Odds against, so bad to good. So this one is actually the same. Odds against getting an even number. There's 3 bad, and then there's 3 good. So it's still go that way. The 3 bad odds against getting an even number, there's the 1, 3, and a 5, and then the 2, 4, and 6. Odds against getting ahead when you flip a coin. There's still 1, which is the tail, and 1, which is the heads. So 1 to 1. Okay. And the month with 30 days. So now we want to go bad. There's 8 without 30 days. And there's 4 with. So there's 8 bad with 4 good. So when you do it this way, it's backwards compared to this one. Okay, it's 2 to 1. That's odds in favor, odds against. I'll give you a trick question, not a trick, a thoughtful question. If the probability of something happening is 4 out of 11, okay, what is the odds for that happening, the same event? Think about that. If the probability of something happening is 4 out of 11, what is the odds for that same event happening? And if you get that one, what if the odds of something, the odds for something happening, so let's just call it X, is 1, 2, 3. What is the probability of that same event happening? Okay, and I'll come back to that at the end of the video, so you can think about that. Okay, the last thing, theoretical probability versus experimental probability. Real quickly, theoretical probability is what should happen. Experimental is what did happen when you did the experiment. So for example, if you flip a coin, what is the probability of getting heads? Okay. If you flip it 100 times, theoretically, you should get 50 out of 100, which is 1/2. Okay, theoretically. But if you actually flip the coin 100 times and you got 54 out of 100, then you just simplify that down to 27 over 50. So in theory, you should have got this, but in actuality, when you did the experiment, you did get that. Okay, and that's a simple thing of theoretical versus experimental. What should happen, what did happen when you did it. Coming back to the questions. Probability of something happening, if it's 4 out of 11. Actually, if you want to pause it now to try it, you can. So pause and try it and then come back. Okay, if the probability is 4 out of 11, that means there's 4 good and 11 total. So if the odds is good to bad, there's 4 good. And if there's 11 total, that means there's 7 bad. So your odds would be 4 to 7. If the odds for something happening is good to bad, this is good to bad, oops. That means the probability would be 1 over, if there's 1 here and 3 bad, there's 4 total. Okay, so just trying to get your brain working a little. If you got those, awesome. Okay, that's section 2.6. I hope you have a wonderful day.